Hello, welcome to Mining Now. I'm your host, Jared Downey. You're joining us for our third annual Australian tour, and to kick things off, we have Propeller. We have their regional sales manager, Kevin Smith, on, joining us from Melbourne. Kevin, welcome to Mining Now. Good to have you on.
Hey, thanks, Jared. Good to be on. Yeah, third time lucky.
Third time. You were on with Sean, joined us for Wingtra once, and then at CIM. This one's done remote. We've got Gowdy producing on site. How long have you been with the company?
Coming up for 8 years now, so I'm one of the almost original people on site, original salesperson here as well. I've moved out of sales, then back into sales, and yeah, it's been a long trip. It was 21st employee 8 years ago, and we're now about 250, somewhere around there. So it's been a good journey and an exciting journey. Yeah.
What was selling like in that first year compared to now?
Yeah, it was pretty chaotic. We didn't really have any tools in place. Pretty much winging it as we went, really. We didn't really have an established target audience as well, where we were just sort of establishing ourselves as being dedicated to that earth moving space. So we were still looking at inspection work and a few other things. So the first few years were pretty interesting, and we sort of found our niche and then tunneled down that essentially. It certainly proved fruitful for us. Yeah.
What do you sort of say to people, like that first introduction to anybody who doesn't know Propeller? How do you describe the company?
I typically mention about we're a drone analytics and mapping company. So we don't really focus too much on the drones. I normally mention it to people because that sort of resonates, drones and tech. The analytics is where I sort of mention what we do, where we measure, we help people measure and monitor their site with simple tools that anyone can use. So I sort of describe it as like a Google Earth for mining, but a bit more technology based and accurate, but tools that anyone can use essentially. Yeah.
The focus of this one is sort of on the Asia Pacific market. Does that, you're doing work, we can focus there, but you're doing work all over the globe though, right?
Yeah. So so I cover APAC for the regional sales manager side of things, but we started off as an Australian company. We've grown from Australia. We've got good sales in New Zealand. Then we started in the US, and we're now pretty much across 100 countries. We've got an office in Europe, office in Denver. We've got an office in the Philippines and also in Sydney. We're truly global now. We've employees from across the globe. We've now got people working in South America as well. So although we started in Sydney, we're certainly global now, and Europe's building up as well.
Wow. I wanted to sort of, you said about you kind of mentioned the drones, it sort of grabs people's attention, but I was looking on your website. Now, you are supplying drones though, because I look at your website and there's platform, which is the Propeller platform, and then there's data servicing, and then hardware, and then it's actually quite an interesting spot on your website because the hardware side of it sort of breaks down these different drones for people that don't know drones in a really simple way. What size of sensors on them, how much they weigh, where they're made, and it sort of have the what size of land you want to cover. So is that hardware sort of the simple part of the business? That what size of land do you need? What size of land do you have? What do you need to monitor? This is what you need, and then it gets into the more technical stuff.
Part of the drone side of things, why we've got that on there. There's lots and lots of drones. There's hundreds of drones out there. Why we've got that there? There's only a few very specific ones that are designed for surveying. And one of the misconceptions that we get from a lot of people who are looking at drones is that they could go down to their local hardware store or local tech shop, buy a drone off the shelf, and then start flying the drone and creating photogrammetry and 3D models. The reality is you can do that and create a 3D model, but it's not going to be accurate. Now, why they've got these specific drones is because they are specifically designed for surveying. So they've got a different camera and they've got high-end GPS on them. So it's sort of the way I look at it and describe it to people is if you want to go and get a model, take a GPS reading with your phone, it's going to be this accurate. If you go and buy a high-end survey GPS rover, which is in the thousands of dollars, it's going to be down to 2 to 3 centimeters. So if you're going to go and build something or measure volumes, you want that high-end accuracy. So when it comes to these drones, why would you bother buying a drone that's a consumer-grade drone that's going to give you a certain amount of accuracy but not correct, compared to buying a high-end drone that's going to give you that couple of centimeters? So these other drones are about 6 or 7 meters accurate. These high-end drones that we've got on our website are down to that 2 to 3 centimeters. So if you're going to be measuring volumes and you've got an error of a few meters, then your volumes are going to be miles out. And that's why we've got that on that website. It's really important to select the right drone as well.
It's quite a helpful layout. People should actually go check it out if they see it, because I've never actually seen just how their drones are properly laid out for exactly what you want to scan. It's quite good.
Let's talk about our heavy industry tour brought to you by Orica Digital Solutions, leading drill and blast into a new era with next-gen Shot Plus. With market-leading design tools and predictive modeling capabilities, next-gen Shot Plus equips drill and blast professionals to effectively improve blast designs and achieve optimal outcomes. Click below to learn more about next-gen Shot Plus. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's heavy industry tour.
The mining industry is evolving. Efficiency and sustainability are more important than ever. Drawing on decades of expertise, Aderco's innovative fuel additive enables you to decarbonize your operations without sacrificing performance. Lower emissions, protect your engines, and save on fuel expenses, all with one simple solution. Choose Aderco, the smart choice for sustainable, profitable mining, because you can save money while making a positive impact. Visit aderco.com to learn more. In heavy machinery, uptime is crucial. Meeting productivity demands with less downtime requires top-notch lubrication. The SKF Lincoln SL6 metering device is built to excel. With a proven design, it handles even the toughest conditions, ensuring reliable performance with extreme pressure greases. This automatic lubrication system reduces maintenance, cuts grease consumption, and extends component life. Plus, its advanced sealing technology minimizes leakage risks. For those who demand reliability, the SKF Lincoln SL6 delivers superior lubrication. Keep your machines running smoothly. Visit skf.com/lubrication to learn more. SafeGauge specializes in innovative safety solutions, ensuring precision and reliability when conducting routine heavy vehicle maintenance. Their award-winning Safe Test range ensures workplace safety and efficiency. Their technology allows live testing to be completed up to 100 meters away, removing technicians from the line of fire and eliminating live work. SafeGauge, work smart, stay safe. Visit safegauge.com today.
And now I wanted to separate out. So now you've got platform, which is the Propeller platform, and then you got the services, which are the photogrammetry processing and the LiDAR processing. So those, I'm assuming, sort of work hand in hand together. But can you just sort of lay that out for the audience?
Yeah. So and why the drones are there? What we've done is try to develop a workflow that can give you accurate drone surveys that are as simple for anyone to actually be able to do and streamline that workflow. So you've got the hardware of the drones, and then we've got a product called AeroPoints. Now that AeroPoint, to get accurate drone surveys, you need ground control. These AeroPoints are self-surveying ground control targets, which means you don't need that high-end GPS gear to be able to get a true coordinate on the ground. That's where the AeroPoints come in. That AeroPoint also acts as a base station for the drone to get that couple of centimeter accuracy. And from that, then we do photogrammetry, where you process that data from the drone. And again, through Propeller, it's very simple. It's literally, the drone captures a lot of series of hundreds or thousands of photographs, all at different spots. From that, you take the SD card out of your drone, you put it into our platform, and we then process that data to create a 3D model. Now, essentially, if you can copy and paste, you can process drone data through Propeller. It's a very simple workflow. It's copying the images and you're dragging and dropping them, and then we take care of the rest. And then from that processing side, then you've got the analytics, which is the platform, because you've got the data, but what do you do with that data? So we've now got the platform that allows you to manage and measure those measurement, that 3D model, to then make meaningful decisions like how much dirt did I move yesterday? You can use the platform to do that. So essentially we've broken it down into the hardware, the processing, and the platform. And you can choose to just buy the hardware and use the error points if you want to use your own platform. You can process the data in other parties if you want to as well. And then you can use the platform as well. So you've got the best of both worlds, and mining's a really good example of that, where a lot of people still process and manage their own data, but they've got no way of sharing that data and being able to use that data. And that's where the platform comes in, where you can use either our processing or you can import the data to then be able to use that platform as well.
So it really is, you've made it so that the entry point is based on need, not that this is our proprietary system, nothing else works with it. Someone has that data, they could plug it into Propeller and assuming they've got good equipment, they could get good results.
Yeah, that's correct. Yeah,
is that utilized a lot? Are there a lot of companies out there that have all this data that just haven't been able to sort of find a good platform to use it on?
Yeah, so like drone and LiDAR, it's very data intensive. Like they are very large files. So typically the surveyor will go and fly, they'll process that data, and then it gets siloed, and they'll come and ask the surveyor, can I have this bit of data, this? And the surveyor will work through that to extract the right data for the person to use. But again, it's all being channeled through that one person, and a lot of the systems are all desktop based as well, which with these very large data like the data processing and the LiDAR especially, these can be gigabytes of data that just chews up a desktop. It's very hard for them to be able to share that data around, and that's where the platform comes in, because it's all cloud based. It then anyone can access that data, grab it, and then just extract the information they want from and put it into their own platforms if they want, like their own mining software. But that cloud-based bit allows them to extract just the information. Instead of using gigabytes, they might be able to use just a few megabytes out of it to be able to get the information they need. So where we see ourselves is being, we reduce that silo. We go between each of those departments as well.
Did you know cementitious binders can be responsible for up to 70% of the total GHG footprint of mine backfilling processes? Now you can replace up to 50% of the binder in your mine backfill operations with Graybond, Graymond's new low-carbon cementitious binder. This lime-based alternative binder maintains a 40 to 70% lower GHG footprint compared to typical cement and can adapt to varying mine conditions without compromising performance. Learn more about Graybond at graybond.com. For almost 30 years, SureStrike International has been delivering high-quality hydraulic impact hammers. Whether you are in aggregate, mining, or industrial applications, they help provide superior output, process flexibility, and remarkable economics in your front-end processing. With hammers ranging from 25,000 to a staggering 150,000 foot-pound of striking force, SureStrike has the perfect solution for any application. It's time to optimize your front-end processing with SureStrike International. To learn more, visit them at SureStrikeInternational.com. As heavy machinery specialists for mining, SMS Equipment knows performance, like the performance they achieve together in a partnership dedicated to the success of their mining customers. At SMS Equipment, they're more than machines from trusted brands. They're the people beside you today and every day, bringing industry-leading technology and expertise to your mining operation. Because the right partnership makes everything possible. SMS Equipment, partners in your possibilities. Discover what's possible at smsequipment.com.
Yeah, that's very interesting. This is a little bit in the weeds, but I'll throw it out there. So is it that data, which is large, there's not really any way to avoid that. It's similar to video footage. It's just large files. And we deal with it. We are transferring it over to editors, and so we have similar issues. So that data that they're extracting, let's say, on their desktop, is that almost like, again, I know I'm getting a little into the weeds. I just find it interesting. Is that like a reflection of the actual data? So they're not having to pull that data, like the software is sort of redistributing the data in a smaller in a smaller format, in a more compressed format, so that it's manageable from all these multiple devices, where that actual data is still sitting in a secure cloud location.
Yeah, so essentially you've got the full, you fly a big area, let's say 100 hectares or so, that is gigabytes of data. Let's say on a mine site, the geology department might want this little section. The engineer might need to redesign the bit of a road down here. The environmental person might need something else. Instead of trying to download, you can visualize it in our platform and see it all in 3D. But when they want to put it into their own package, like to redesign that road, you don't need all of that data, because you only need to work on that little bit of road that you need to redesign. So that's where our platform comes in. Yeah, you can just draw a boundary around that little area and extract the information from that. Yeah, and that's what reduces the file size down. We're not compressing it. We're actually just allowing them to get the information they want from the area they need.
I see. Yeah. Okay, so they're downloading it in full, and then they can use it till its full potential, because that's a full file size.
Yeah, it's a full file size, but it's just a section of the information that's actually been captured.
Oh, that's interesting. Again, I don't know if anybody listening, that's a little in the weeds, but I was curious how it was designed. Water management. Now, your platform's used a lot for this. Can you talk a little bit more about that?
Yeah. So because we create these accurate 3D models, we've just released a hydrology tool, which essentially shows how water flows and how you can manage water on site. So there's 4 different tools that we've got, and one of them's the very first one's just picking a flood level. So if you've got an area of a mine that's typically used to flooding, you can click a location and it will show you where that water will flood to. It's essentially just a contour file, but it's a very easy way to visualize in 3D how that water will look. Now, the next step from that is we've got a product which is called surface runoff. Now, the surface runoff essentially mimics how water will flow on site. So it visualizes in 3D how water will flow around the site. Now, where it comes in very handy, we've got pretty smart engineers who've done this. We've got a hydrology expert, and we've got a really good visual graphics guy. And so it looks fantastic. What you can see is if I turned on like this waterfall or the rain effect, it will show you on, let's say, a haul road, where water is being channeled down either side of the road that you want it, what the cross slope does. But if that water then crosses across your haul road, before it rains, you can visualize where it will cross over, and then you can go and put some mitigating effects in. You could put a channel in, you could build a bund to redirect that water. So before it rains, you're not going to wash away. You've actually fixed it before the issues occurred. So it's really good for pre-planning any events that, especially in Australia, it's pretty much drought or flood. So, and especially where a lot of these mine sites are, they're up north, they get very big rainfall events in a short amount of time. You can plan for what's going to happen before that rain event occurs. So I've seen lots of people using that to actually cut channels into their haul road before it, so that half the road doesn't get washed out when it rains.
Wow. So could you just explain the environment a little bit? So how long would a dry period go, and then how a rain would come for what, like a couple days of just sort of torrential downpour?
Yeah, so up north, depends where it is. In Queensland way, they get tropical rain, so like monsoon season, where it's dry for half the year and then rains intensely for 6 months of the year, or maybe 4 months of the year. In Western Australia up north, it's the opposite, really. They just get cyclones that come in. So they get very, very large events. It's hit and miss where it's going to go, but it's typically dry. But when these rain events do occur, you're looking at 100, 200 mil, 300 mil of rain in a couple of day period. So it's very hard to try and plan for an event like that when your mine model might be out of date. And that's where drones and Propeller sort of comes in. You can be modeling something from a flight that might have been done 6 hours ago. So you're really capturing exactly what is there, and as opposed to capturing something that was captured 4 weeks ago or so. So The next sort of stage for that hydrology one where you can see where it flows, we do have a tool now which is a catchment area. And that sort of takes it to the next level where you can visualize the water. This one will then tell you where the water's come from and where it's going to. And it creates a stream network. So essentially you can click on this stream and it will show you the catchment area for where all that water's come from, and it will give you the square meterage as well. And this is really handy because not only tells you the square meterage, if you know the square meters and you know how many millimeters of rain you have, you know the volume that's going to be flowing through that channel, which means you can work out what size pump you might need down the bottom to avoid flooding, especially with these big rain events. It's also really handy because you can see where it's coming from and you can see how it's all connected in this network. You can choose where you want to redirect that network. So if you don't want half the water coming from an area, you can see this channel and you can then, let's say, cut a drain in from one section to another section, and it might only need a 20-meter drain to fix a whole area of water that would have eventually ended up in the bottom of your pit. It's really handy to visualize just how everything is connected on that rainfall event.
Do people, when you're talking to people about this, I mean, I look at it because I'm looking. We've just brought them up on screen. These presentations that you have. Are there what are the roadblocks to this? Like it's one of those things, and I'm sure I said it last time, or no, I didn't do the first interview with Propeller, but on with Wingtra. You did an episode with Wingtra. It's almost so you almost can't find a reason not to do it. So I was just curious, what are some of the roadblocks for it, though? What do you run into on the field where someone looks at it and goes, we don't need to know that, or we're not sure about the technology because of this reason, or we had a bad experience 5 years ago? What are some of the things? You're out there actually in the sales side. So what do you run into where it can cause a roadblock for people?
A lot of it used to be being cloud-based, and the fact that a lot of these mine sites are remote, so the internet speed just wasn't there. Thanks to Elon Musk and Starlink, that's no longer an issue. Yeah, so it's probably one of the things that a lot of mine sites haven't jumped on board fully yet, but we've got lots of customers now who have just got Starlink, and they're getting 100, 200 megabytes a second out in the middle of the desert.
Even their upload speed is good as well? Wow.
Yeah, their upload speed is fantastic, which means that a lot of the arguments for not using cloud, it's sort of gone away. And it's where we come into it is, Propeller, because we do cloud-based processing, a lot of people, if they do it on their laptop, you need a high-end, high-powered laptop with really good graphics cards, about $10,000 computer. They would process it on their laptop remotely and then have it for everyone. Now with Starlink and what we see people doing, they've got Starlink on their cars, on their mobile. It allows them to capture multiple surveys in one go, drag and drop them into Propeller, which is just a 5-minute job. And as they're driving back to the mine site or even up the ramp, this is already processing in our system. So by the time they get to the top, in some of these mines, I used to work in one, it could take an hour and a half just to get to the top, maybe 2 hours because you're stuck behind a truck. By the time you get to the top, it's already processed and ready for everyone to use. The surveyor's not being bogged down with just processing data. They can actually fly, let us, Propeller, do the processing for them, and by the time they've got to the top, everyone's got access to all this data. Starlink's definitely changed the way people perceive cloud computing because it's now no longer, you're not restricted to where you can access the internet.
Yeah, I was just, I literally, I said before going, I was just up in the mountains hunting, and I'm here in BC, Canada. And, we've got a little cabin up there, and, that'll be rigged out with Starlink. It's probably going to be in about 48 hours, actually, which is kind of sad sometimes because it's kind of nice just shutting it all off. Yeah. But anyway, I didn't make that decision. But it is just incredible. Yeah. Like, I lived up in remote areas when I was growing up, and I mean, you had to jump on a bike if you wanted to use the phone. Like, it was way up there. Now that's all going away. Like, it's in these flooding areas, that's happening in the U.S. They've got full speed. They've got faster speed. They've got faster speed internet during a flood than they had before the flood because of Starlink. It's absolutely incredible. Are people pretty educated on that now? Like, are you seeing a shift even in the last year?
Yeah, definitely. The shift it used to be a big objection. Now, if they haven't got it, they're looking at it. And a lot of these mine sites, in the mine site itself, they've got typically good internet, and where the mine camps are, they've got mobile phone coverage. But it's when you start moving out, like where our systems come in really handy with this hydrology, is when you get into the environmental teams. A lot of their work is in the rehab areas that are off-site, away from where the Wi-Fi is. And so what we're seeing is, because Propeller is very easy to use, the environmental teams are now getting access to this data where they can make decisions themselves instead of seeing something out there, then having to drive back, find out what's wrong, and then go back out again. They can actually do all this from their car because they can have Starlink on their car and access all this information that they've never had. And Propeller sort of sits in between. You've got the high-end technical mining softwares, then you've got your sort of lower-end GIS software. And where Propeller sits is in this middle ground where we're really accurate but very easy to use, like the low end. So we don't do the design side of things like the high-end mining products, but what we do is answer questions very quickly for people on a mine site, where if, let's say, the rehab's been done, an environmental engineer needs to go and sign off that the rehab's been finished and it's on design, they can go out there and actually within probably 3 button clicks answer that information themselves, that it's on design. They can draw a cross section in 2 button clicks to show them whether that part of that mine or part of that waste dump is on design. And previously you'd have to drive back, they'd have to get a surveyor out, then they'd have to check that, and it would all have to be done from the office. Now, with Starlink and the way mobile phones are as well, the environmental engineer can go out and actually do that on their phone in Propeller while standing at that location. So that's probably one of the biggest shifts that we've seen, especially in the last year. And again, like you mentioned with the hydrology tools, that currently only works on a laptop. But if they've got internet, they can do the exact same thing. They can turn it on. One of the last hydrology tool that we've got is called a direct rainfall event, and you can load in the hours in a table, a CSV file, and it's basically hours, and then on the right hand side it's millimeters per hour, and it will actually simulate how that water will flow, where it will pool on site. And so if you're an engineer out on a job, you can run this for a rain event that might occur tomorrow and see where you will have low spots, where it's going to pool, where water might spill over a batter and wash away all your topsoil rehab that's just been done. And you can fix all this before it rains. And you can actually do it out in the field while looking at the information there. So it's very, very handy where the collaboration comes in. You've got the mining engineer, you can have the environmental engineer, and you can have like the supervisor and foreman all looking at this information to show you where low spots and then make decisions on where they're going to fix these issues before the rain occurs. So, the tools are now sort of working, especially for I've been 8 years. The workflows now mean that we can get across a lot of these teams with just specific workflows that they've probably never had access to before. Like environmental engineers, trying to do that in any other software, it's very difficult. And within Propeller, it's probably 2 button clicks.
Wow, it's absolutely incredible. Are there a couple of examples before I let you go? Are there a couple of examples of companies you've worked with? It doesn't have to be in the water management, or of course it can. Just that sort of stand out to you as good projects. You say these are a good example of how Propeller offers value, but also how people realize that value sort of over the times of adopting the platform.
Probably there's a couple of mines in the US and there's a few now in Australia that have adopted the same workflow. And essentially, they're utilizing our whole end-to-end. So they're using all the processing, they're using the error points, and what the workflow is essentially they'll, every day, they mine a certain area. There might be 2 or 3 different areas that have been mined overnight and yesterday. What they do in the morning is they'll go to those areas, put one error point down, fly the drone, then upload in the laptop as they're driving to the next area that's changed in the next area. When they're driving up the ramp, that's already processing. So by the time they get to the top of the ramp and the morning meeting, which is at 11 o'clock, they've got a brand new 3D model of the entire mine site that people can make informed decisions on. So their planning meeting with the engineers, they've actually got a model that was only captured a couple of hours before of the entire mine, and then they can plan, how much volume did we move here? Are we on design? Where are we going to go to next? And they can see it all in 3D and use that on the big screen in their morning meeting from something that was only captured 2 hours ago. And to me, I'm a mining engineer and mine surveyor from a fair while ago, and that sort of blows my mind a bit that the information I used to have to capture that would have been maybe a day or two of walking around with a total station and a prism can now be done in like 15 minutes and more accurately. Like I was picking up a point every 20 or 30 meters. The drones are picking up a point every 3 or 4 centimeters. So it's pretty amazing. It would have saved me a lot of kilometers and miles on the boots for sure.
When you look at that, we'll get to the next example if you want as well. But was there ever even was there how quickly in the mining industry did there start to be conversations that this would become a reality of what's happening? Because it's once something's on, after about a month, everybody gets used to it being part of the industry. But like you said, a little while, not that many years ago, it was like, were there people even talking about it? Was it conceptualized, like on the ground at mines?
Not with drones. Like we used to have our mine flown every 6 months by a plane. So photogrammetry has been around since pretty much photographs have developed, like hundreds of years, well, probably 100 years or so. But drones allowed that concept to then, you don't have to get a plane. It's not going to cost you $30,000, $40,000, $50,000 to get a plane survey. It's now going to cost you $3,000 and to put a drone. So it was when the drone technology started, and mining, like everything, probably leads the tech in all these spaces because they've got the money. So mining started with the drones, and then it's flown out. It's gone to all the other industries that we service. But yeah, it's still, like now it's become mainstream. When I first started at Propeller, the very first question everyone asked was, how accurate is it? Is it accurate? No one even questions that anymore because everyone knows it's accurate. If you have the right drone and you have the right workflow. It's sort of, I started at Propeller in 2017 and I could sort of see the potential of where it was heading. But now it's definitely, you wouldn't see a mine site without it really. Because you can't, there's no other way of capturing such a big area in such a short amount of time to the same accuracy that you can.
Any other examples of that stand out to you as examples of people adopting it?
So like even a lot of the civil mines have obviously got lots of civil projects on the tailings dam. Like tailings dam management is something that I used to do. I used to hate. It's a horrible place to walk around. You've got all this dust and it's not a nice place really to walk around.
That's actually a good. You're referencing it. I want to go into it for a second. So, what was the job before? What did you have to do on site?
So I would surveyor. I would, we'd set points out and we'd pick points up. So volumes, basically walking around, capturing what had changed overnight. So if a digger had come in, they'd taken a heap of dirt and it's end of month, you've got to walk around where that is, capture those points like toes and crests and walk around and then stitch that into a model, to then create a volume for the end of month payment so people would get paid. That was the capture side. The stakeout bit was then showing where the digger needed to be dug. If you're building a ramp, where is it going to end? The way it's changed now is, our end of month surveys would have taken, it finished on the 1st. The end of month pickups pretty much start straight away. You're just constantly surveying that place. And then the very end of month is probably 2 days or 3 days of solid walking around to pick up points. Now you can just fly a drone and it will do it for you. Like it's a lot safer because you're not walking around where the machines are. You're not walking where rocks are going to fall on you. Tailings dams, you're not getting dust all blown into your face, and you can't survey the middle of a tailings dam. Even with a laser and a total station, it just can't shoot far enough and reflect back. So a lot of you just basically had to guess what the middle of the tailings dam looked like, because there was no actual way of surveying it. You could survey maybe 200 meters in with a laser, but these things could be a kilometer by a kilometer, even 2Ks by 2Ks. So now a drone can fly these inaccessible areas and actually get true volumes of things that you would never be able to capture before. So it's definitely been a game changer for the way things are managed on site.
Do you have any insight? I know I cut you off for getting to the example, but do you have any insight into some of these? I mean, these terrible failures that have happened in mines that, compared to the tailings all the tailings ponds that are around, it's very minimal, but one is too many. So some of these failures, do you have any insight? Have you looked at any of them and seen that if people had been using this scanning technology, that some of those could have been avoided, just because, like you said, that the middle of the tailings pond, you're just guessing, like you actually you're not getting out there. Do you think some of that could have been avoided, or have you ever looked at any of it?
Yeah, we've certainly got customers flying tailings dams pretty regularly to capture information of movement. Like drones are accurate to about 3 centimeters. Typically, you're looking at maybe a bit smaller, but one of the problems with old monitoring methods is you had a total station, you had prisms on the wall, and you're monitoring where that prism is moving. So you take a coordinate of that prism and you measure the X, Y, and Z. The problem with tailings dams and things, if you've got 100 meters between each prism, if something fails in between those 100 meters, you're going to miss it because you're capturing something here and here, whereas a drone can capture that entire thing. And when these things fail, they don't just fail. They'll start bulging, they'll start moving, you'll see cracks, you will see something happening. And that's where drones can capture these big areas very quickly and more frequently. No one would do it, typically walking it, because it would take so long. Whereas a drone could capture this in half an hour. And you can capture and LiDAR drones mean you can shoot through vegetation now as well. And even that 2 to 3 centimeters accuracy that we get, that's typically enough to actually see a bulge and a movement in those tailings dams. So we've definitely got customers doing it and managing and it's just part of the other tools that they use to manage those tailings dams. It's not the be-all and end-all because of the accuracy of it, but it's used in conjunction with the prisms. It's used in conjunction with stress monitors. Propeller's got a really good tool, which is a timeline, and basically every survey, you can go back in time and merge each survey into the previous surveys, so you can have a history of how things have changed, which is really handy. If you look into, you might see a crack, and you go, when was that crack? How long has that been there? And you can go back and back and back, 2, 3, we've got customers who've been using this for 7 years, all the way back, to see whether that was there and when did it occur, to then now, and also visualize whether it's expanded or not. And previously, if you think of GPS and the way I used to do it in total stations, it was just a line on a black screen. But now, because you can measure and visualize that with the photogrammetry, you can physically see if something's changed as well. So that's been one of the big game changers as well.
Wow, I really took you on a rabbit trail. My apologies. What was the example you were going to use before I took us on a completely different direction?
No, it was the tailings dam. It was actually measuring those tailings dams of the actual middle of the tailings down for the volume because you physically can't get there. The drones are you can actually fly the drone where high wall monitoring is something that, once a digger's taken something off, you typically can't, and that's one of the reasons with our end of month surveys, we used to have to start surveying straight away, is because once a digger's taken something off, you physically can't get back to that location. Whereas a drone can now just fly wherever and capture that. So,
right. Yeah. And and again, you're not spending $50,000-$60,000 to do it on a plane. How close to peak is this sort of stream of technology in the mining industry? Is it just more of a matter of scale and more people using it, or are there just from your R&D team and your technology side of the company, do you get a sense that there's another 10 tiers for the technology to go, or what sort of happens from here?
The cost is always coming down, especially with the drones, the larger drones. I think probably where I see it is it's more, and we're heading down this path now as well, it's more the blending of the different technologies. So when I started, we were purely drones. Even last year, everyone thinks of Propeller as a drone company. Where we're heading is the fact that we're now bringing in laser scanners, we're bringing in GPS surveys, we can bring in machine data and visualize that all in 3D. So what I'm seeing and what we are seeing is a mixture of, this used to be my machine data, this was my survey data from my total station, this is my data from my laser scanner, and then the surveyors would have to mix all that in and try and create a model. Now what I'm seeing is all this data can be fed in to Propeller so that you're not, if for some reason you can't fly a drone, like there's a cyclone, it's raining, you can bring data captured by a total station or a laser scanner into Propeller and use the same tools. So we're no longer just this drone-focused sort of company. You can bring everything in. A good example, we've got a product which is called DirtMate. Now, DirtMate is sort of a low-end fleet management system. And what we've done is tied in the drone survey with data captured by machines, like actual surface data captured by machines, to then create an updated 3D model of your site that is updated every 30 minutes. So you can get volumes every 30 minutes from a very low-cost system that actually matches into your drone survey. So it's essentially, you've got your drone model. If a machine drives over an area, it will change that surface and we'll match that surface into the drone and update that drone model so that now you've actually got a live working model of your mine site. And that's sort of what I see is, the next step for Propeller and for a few other technologies is the blending of these different tools into the one system.
So you're talking about like the haul trucks and they're actually speaking with your software and it's creating, so you've got the up above, but now you also got on the ground and it's all merging together is what we're talking about, right?
Yeah, so DirtMate essentially is a small GPS antenna that you put on on a truck, let's say a haul truck. That is a high accuracy GPS antenna, so it's 2 centimeter accuracy. We measure the width and the height of where it is down to the ground, and then as that truck drives around, it's essentially capturing that surface as it drives. So if it drives over an area that the digger's just taken away or dozers pushed dirt, that will update the ground level to then and update our model to show you what's changed in that. So it pretty much turns every machine into a survey capture device. Really handy on any mine site, really. The smaller ones, really good because they can't afford the high-end fleet management. This is a really affordable model that allows people to have up-to-date volumes and information. Instead of just every drone survey, you can get this every 30 minutes now.
Wow. I have to ask, I'm just curious. You talked about walking around on the tailings pond. Have you ever had a mine just say, like, you go through similar conversation that you just had, you showed them, you got everything done, they went, no, this is the way we've done it, it's working. Have you ever run into that?
Plenty.
Oh,
Plenty.
really?
A lot of it is Drones, they still process themselves, but then when we see the workflows and this is how it can go across your teams and everyone can access all this data, we do have ones that go, well, do they really need it? And like, well, the environmental team, give them access to something that's actually going to make their life easier, not harder. So yeah, we definitely see. It used to be the case that drones were the same, like no one would touch the drone. Now there's not many mine sites that wouldn't. We still get that in the construction space where they will just tick along and just carry on from what they've been doing.
They just don't want a drone. They just don't want something flying above them, essentially, right?
Yeah, I think they think it's too hard. Like the drones, once you get the right license and you're flying, the drone's the most boring part of the whole thing because it takes off, it flies itself, and it lands itself. You literally don't need to touch anything. So it's exciting for the first few flights, and then after that, it's just you're just watching this dot in the sky just go backwards and forwards and then comes down and then it lands. Unless the most exciting thing in Australia is you've got wedge-tailed eagles that do like to have a good look at drones and can take a few drones out. So
they'll take a crack at them.
Oh yeah, there's plenty of drones. There's some good videos online.
So was my next question. Is there videos of this online? Okay, well, we've given the audience something new to search now. Okay, what kind of eagles?
Wedge-tailed
eagles attacking drones. Australia. There we go.
You'll find it straight away.
Oh, that's the first thing I'm going to search after this interview. Kevin, thanks for doing this interview. Thanks for joining us from Melbourne. This third time doing this Australian tour. It gets more and more fun. We get more and more partners every time. So thanks for being first up. And I'm sure we'll do it again soon.
Nah, all good. Thanks for having me.
Thank you. And thank you, everybody, for watching. Make sure to check out. We've got Propeller's website will be in the description below. A link to their LinkedIn. Kevin's on LinkedIn. You can connect directly with him as well. Their YouTube channel has a whole. I was looking on it today. They've got a lot of content. It looks like about a year ago they really started pumping the content up. So there's a ton of stuff to look at in all these different segments. Really interesting. Go check that out. Thank you for watching. Make sure to subscribe. We will see you on the next episode of Mining Now.